See the third question, students. The given function is sine of ax square plus bx plus c. We need to understand the angle of sine here is ax square plus bx plus c. I take the whole thing as y. So y equals to sine of ax square plus bx plus c, and then I will differentiate as usual as we did in the earlier two questions, differentiating both sides with respect to x. You can write in short, this is allowed. This is DIFF dot, that is differentiating with respect to x, WRT, this is also allowed with respect to x. So d by dx of y is equal to d by dx of right hand side. Now once again the same thing. You remember what I said? I said recognize the function. Recognize the function that you have to differentiate. Why is that required? Because if I do not recognize the function, how would I apply the result? So now I say, what function is this? You need to name the function. Come on, give me the name of this function. This function, yes, you all are right. This function is sine function. But remember, students, it is not sine of x. It is not sine of x. Why? Because you see the angle which is not x. What angle is this? It is f of x. It is something in x different from x. So it is not x, it is, so here we have d by dx of sine f of x. And you know what is d by dx of sine f of x? It will be cos f of x d by dx f of x. Okay, I would request you to write those results which I had given in lecture number 2 again and again, and get the practice of that. So cos f of x d by dx of f of x. After that, cos f of x, this cos of ax square plus bx plus c comes down as it is, and here then you have product sign and d by dx of ax square plus bx plus c. What happens next? You write d by dx of ax square, d by dx of bx, and d by dx of c, and in between you have plus sign, so you use the theorem of sum of functions. So here you will write plus sign, so d by dx of ax square you wrote here, d by dx of bx plus c you wrote here, bx, and then plus d by dx of c. So now ax square, d by dx of ax square, a is a constant, a is a constant. Here you are using the result where you have a constant multiplied with a function. So ax square, what happens? This a will be taken out. So it is, see here, you see this a out here. So a into d by dx of x square, then d by dx of bx. Once again, same kind of rule you apply. B is a constant which is multiplied to x, so b will come here, b and d by dx of x plus d by dx of a constant. There is no x here, so it is a constant. It is independent of x variable, so it's a constant. Derivative of a constant is 0, so you have written derivative of constant 0 here. Now students, problems we will we'll be solving these kind of steps faster. But as of now, in earlier few questions, you will find that I'm writing all the steps for the sake of better understanding. So if you want to skip such step, you can always do that. There is no problem in it. But as a beginner, I'm writing, as we are beginning, I need to understand, you all are beginners, I need to make you all understand very well. So I'm writing all the steps. But skipping all such steps will be automatically done as you become more well versed with these kind of questions. So a is out, d by dx of x square you wrote. You all know what is d by dx of x square. D by dx of x square is 2x. So it is a into 2x. D by dx of x is 1 and this is 0. So 2x into a is 2ax plus b, and here you have the answer. There I did not speak much about the first factor because it is copied as it is. Okay, so I hope you understood this thing. If you want a revision of this, you can just go back and listen to the and see the video once again. Now the next one is question number 4, and question number 4 here, the given function is a root of square root of tan of root x. Look at the function, square root of tan of root x. So the first step, I is equal to square root of tan of root x, differentiating both sides with respect to x. So d by dx of LHS and d by dx of RHS, which is square root of tan of root x. Then once again same thing, you all know what I'm going to write. recognize the function. Recognize the function. So what is the function here, dear students? Recognize the function. It is d by dx of root f of x. D by dx of root f of x. So 1 upon 2 root f of x into d by dx of f of x. What is f of x here? F of x here is tan of root x. Okay, I will do this part once again for you. See, I will do this part. What I said this function is, see, this function is d by dx. This function here is root f of x. What is the function? Root and then f of x. You know, d by dx of root f of x. What it will be? It will be 1 upon 2 root f of x into d by dx of f of x into d by dx of f of x. So 1 upon, you can now have a comparison between this part. Compare this part with this part. So what you see, d by dx of root of tan root x. So what is f of x here? If I ask you, comparing from this, what do you see? What do you see as f of x? F of x is tan of root x. See, root f of x, root tan root x. So f of x is tan root x. So what will be derivative of root tan root x? 1 upon 2 times root tan root x into d by dx of tan root x into d by dx of tan root x. Then next step. Then this part you write as it is into, now here once again same thing, d by dx of tan root x. I need to write derivative of tan of root x. How do I write it? I recognize the function. I ask myself, what kind of function is this? So the answer is, it is tan function, but it is not tan of x. What it is? It is tan of f of x. It is not tan of x. It is tan of f of x. You can check, this is not x. What is it? It is root x. So it's in the form d by dx tan f of x. You know, d by dx of tan f of x is sec square f of x into d by dx of f of x. So this will become sec square root x into d by dx of sec square root x into d by dx of root x. Now here you have d by dx of root of x. What is d by dx of root of x? D by dx of root of x is 1 upon 2 root of x. So this thing is copied as it is, 1 upon 2 root x. This thing is copied as it is, and this is, and then all are multiplied. The last step is only the simplification part. The last step is only simplification part. See, 2 into 2 becomes 4, then root of x 4, and then root of x, and then root of tan x. 4 root of x and root of tan of root x. So this is your final answer.